Looking at example 1, say we want to determine the node voltages using node voltage analysis. We want to do this symbolically. To begin, we will follow our 4-step procedure, where the first step is to assign our nodes, which we have designated A, B, and C, where C is our ground, and also assign our leg currents, where I1 runs through R1, I2 runs through R2, and I3 runs through R3. Step 2 is to assign voltage potentials consistent with our past assign convention. V1 corresponds to R1 based upon the direction of I1, V2 corresponds to R2 based upon the direction of I2, and V3 corresponds to R3 based upon the direction of I3. Our third step is to construct our KCL equations, where we will have n, our number of nodes, less unity, less our number of voltage sources. Thus, we need one KCL equation. And we will apply this to non-zero and non-specified nodes. By non-specified nodes, we mean node A already has a value. For the voltage at node A is our voltage source Vs plus the voltage at node C, where node C is equal to 0. Therefore, our nodal voltage value at A is equal to Vs. Thus, if we apply our KCL equation at node B, we have Is is equal to I2 plus I3. Step 4 is to apply Ohm's law in terms of our node voltages. That is, Is is going to be equal to I2, which can be expressed as VB minus VA over R2, plus I3, which can be expressed as VB minus VC per R3, where VA has a value of Vs and VC has a value of 0. Thus, VB, the voltage at node B, can be expressed as our source current times R2 times R3, plus our source voltage times R3 over the sum of R2 and R3.